Okay, this is 8th grades, 8.1.3 lesson titled What Patterns Can I See? And then it says linear and exponential growth. So that's exponential growth is a new concept we're going to learn today. So the intro says patterns in tables, graphs, and expressions give clues about the kind of growth that is being represented. Today we'll work to identify whether a table, graph, or situation represents simple interest or compound interest based on the kind of growth that is shown. You'll also compare different kinds of interest in situations to see which one is a better deal. So we're going to be looking at lots of patterns today and figuring out the type of interest and what's the differences between both of them and how they grow. So this 8-24 is quite a hefty problem because it's describing, I'll first read it and then I'll tell you why it's a little hefty. John needs to borrow $250. Moneybags Municipal Bank will charge him 8% simple interest each week to borrow the money. Scrooge Savings will charge him 6% compound interest each week. Wants you to help John decide which loan is the better choice. So part A says make a table for each bank. Now it wants you to show the amount he owes after each week for 12 weeks. So these tables are going to be pretty long. I'm going to show you like the first 5 values and then you guys can finish the rest because it's just going to it's going to be taking you a long time and it's literally just a pattern that you guys are following for it. So I'm going to fill in the first So I'm gonna write, I'm just gonna erase this A because I need more room. So money bags, I'm gonna call the first one money bags because that's the bank. And then the Scrooge is the other bank. So let's see. Here's the weeks, the balance, weeks, balance. Okay, so let's go through, I'm gonna put in 5 weeks, 0, 1, 2, 3, 4, 5, but you're doing 12. 0, 1, 2, 3, 4, 5. Okay, so he has, his principal is $250. So his principal is $250, that's how much he puts in to the account. And Moneybags, I believe, does, yeah, Moneybags is 8% interest, simple interest. And Scrooge is 6% compound. So what we need to do is start at 0 weeks for both, which is going to be $250. So let's do Moneybags first. So we know that simple interest goes by the same rate every week or month or year. So it's going to be $250. We need to figure out what the rate is. $250 times 0.8. And $250 times 0.8 is 20. So that's how much, that's the rate. Every single value is going to be by 20s. So let's do 250 plus 20 is 270, 290, 310, 330, 350, and so on to 12. So there's Moneybags, first 5. The compound is going to be a little different now. So the compound, we need to take, I'm going to erase this, 250 times 0.06 to do the first value for the first one. So that one is it's $15. So it's $265. Now is where it's different, how we do the pattern. So now we need to take 6% of this 265 times 0.06, and that is 15.9. So 265 plus 15.9 is 280.9. 280.90. So for every single new value you have, that's what you have to plug into this new equation. So 280.9 times 0.06 is 16.85, and then you have to add this to that to get your new value, and it is 297.75. Okay, same thing, we gotta take that out. 297.75 times 0.06, I got 17.87. Is that what I got for number 4? Yeah. So then if I add 17.87 plus 297.75, I get 315.62. Obviously a calculator is going to come in handy for this one. Okay, let's do the last for mine, 5. Week 5 is going to be 315.62 times 0.06, and that's 18.94. So 18.94 plus 315.62 is 334.56, and so on and so forth down to 12. Okay, so those are the tables for part A. For part B, it wants you to graph both. So this would be your X value, that would be your Y, that's your X, that's your Y. So there's going to be 2 lines on the same graph. My graph came out not so great because I don't have graph paper. I'm going to show you what the graph should look like on the answers. Okay, so I'm going to show you. I'm going to take this off. Hopefully nothing bad happens. There we go. Okay, so it wants you to graph it, and here's what the graph looks like. So you'll see the weeks, and go ahead and you can sketch this on your paper. So weeks are on the bottom on the x-axis, goes by 2s, and then the money owed, the balance, goes on the Y, and then there it looks like they're going by 50. So 50, 100, 150, 200, and so forth. So they both start at 250. So they both start there, that's their first point, and then as you graph each point, like the first one for money bags is 1 over 1 up to 70 would be like right there. So you're just, I would sketch it so you'll notice one of them's curving. One of them has a slight curve to it, and then the other one is a straight line. So I want you to realize that simple interest will always be a straight line because it's going up at a constant rate. Compound interest will have a slight curve or a curve. It might not even be slight, it might be a drastic curve. This one's a very slight curve, so it's going up and up and up and up. So that is what the move right along from part B with the graph, and we're gonna look at part C. In part C, oops, I gotta get back on my right screen. Part C says, which bank will charge him more if he pays the loan back in 12 weeks? Should he choose the same bank if he plans to pay back the loan in just 4 weeks? I'm gonna give you value 12 here, so we can answer this together. So value 12 in 12 weeks, I calculated. This would be 490, and the other one is 503.03. So it says, which bank will charge him more if he pays back in 12 weeks? So you can basically look at the table. What did we just write? Which value is greater? This one will charge him more. So Scrooge will charge him more if he pays it back in 12 weeks. But then it says, should he choose the same bank if he plans to pay it back in 4 weeks? So let's look at the 4. I know mine are a little off. Okay, so there's 4. 4 is 330, and then 4 is 315 here. So I would not choose Scrooge for the 4 weeks. I would choose Moneybags for the 4 weeks, because theirs is, wow, why did I say that? Scrooge is less, so I'm going to pick Scrooge this time. There we go. And theirs is more. I got it. My brain's okay. So yes, I would choose Scrooge for 4 weeks, Moneybags for 12 weeks. Okay, part D. I need to erase my stuff because we've got some vocab words coming in. That was quite a hefty problem. Part D, simple interest. Is an example of linear growth. And linear means straight lines. Okay? Linear is straight lines. Constant rate. Compound interest. Is an example of exponential growth. So this means it can curve. And it can also curve down that way too. So the two different types of growth goes up by a constant rate, does not go up by a constant rate. And it's interesting because I've been seeing, if you watch the news or if you watch the White House briefings every day, which are quite entertaining, you'll see a lot of graphs that have, you'll see a graph for coronavirus, and it would have like the city or whatever region, and it would show like day 1, 2, 3, 4, 5 of the coronavirus, and you'll see that it goes like slowly, and then it starts to like ramp up, especially for like Italy and stuff and New York, because the rate of the spread of the virus might have been slow at first, but then all of a sudden the rate just skyrocketed, and it was going up. I mean, every single day it would just go up and up and up, more and more and more. It wasn't going up like 15 people each day got coronavirus. It was like 15, then 45, then 100, then 200, then 300, then 500. And so that would be an example of like real life exponential growth going on right now. So there is a reason for this kind of math. Okay, moving on. 8-25. Let me check that it's still recording because I messed up earlier. Okay, good. Oh, where's my eraser? 8-25. So this is kind of the problems that we're going to do next. The rest of these are not as time intensive. Does that make sense? I don't know. Not as much time is needed. Here we go. So here's the table. It's in your book or on your screen, and it has Devin's bank account for the last 5 months. Has he been earning simple interest or compound interest? So I don't really want to write the table right now. Yeah, I'll write it. Here we go. Doing it. Committed. Time. Balance. Maybe I can try editing. I'll try editing my videos so that it goes through all this and speeds it up. Also with my erasing. Because just feel like I'm wasting time here. I'm wasting your time by putting stuff that's already in front of your face. I need to see it too. 25, 286.25. Okay, so what I did is I started by subtracting this number from this number because I want to see the difference, what you add here to get here, and I got 575. Add it, and then I did the same thing, 269 minus 263.25, which was actually the same thing, 575. So I'm like, okay, it looks to be simple, but let's just double check here. Did the same thing, 274.75 minus that. I also got 575. Looks like it's checking out. 280.50 minus that was also 575. And lastly, this value minus that value was also 575. So it is confirmed. This is simple interest because it is going up at a constant rate. I feel like I need to do like Dora the Explorer and be like, it's an example of, and then you guys say it. Just go ahead and yell at your screen. Just yell the answer at your screen. Nobody can see you. Well, maybe your family, but. Okay, 826. We're almost there. Almost at the end. Imari borrowed money from her uncle to buy a new bicycle. She made the graph at the right to show how much interest she'll need to pay him if she pays back the loan at different points in time. I'm going to take the camera to show the screen. All right, and we're back. So it says, part A, about how much interest will Imari owe her uncle if she pays him back in 3 months? When will she owe him $40 in interest? Let's look at the graph. It's asking after 3 months. So we have months on the bottom, interest on the Y. I shouldn't say bottom, I should say X, sorry. So let's look at 3 months and let's move up to about this little area. And it looks to be about, I don't know, what, $17, $18. So I put for part A, I put maybe $16 to $18 about, because it says about. So we're kind of estimating here. And plus it wasn't directly on the grid, it was like in the middle. Okay, and when will she owe him $40 in interest? So let's go to $40 in interest. So here's interest, $40. Let's move over until we hit the black line. Ah, right there. So about 6 months. So I put it's about 6 months she'll owe him $40 in interest. Okay, now it says for part B, is Amari's uncle charging her simple or compound interest? So go ahead and look at it. Remember what types of graphs are which for which interest. Simple is a certain way and compound is a certain way. And you can shout it at the screen right now, but I'm gonna tell you in 5, 4, 3, 2, 1, it is compound interest because it's curved. It's not going up at a constant rate. And it says, how would the graph be different if he was charging her simple interest? The graph would be different because it would be a straight line, constant rate. Sweet. Done with that one. Okay, now I think I need to go back to I'm going back to the whiteboard. See you in a sec. Okay, 827 says, Tom has a choice between borrowing $250 from his grandmother, who will charge him simple interest, or borrowing $250 from the bank, which will charge him compound interest with the same percentage rate for both. He plans to pay off the loan in 8 months. So here's how he wrote the two expressions to figure out how much he would owe for both of the options. So here's the first option. He put 250 times 1.02, and then he put to the 8th power. And then the second one says 250 plus 8 times 5. So now it says, per part A, what percent interest will he be charged? So it says, where can you see that percent in each expression? So here's expression 1, here's expression 2. So expression 1 is pretty easy. I can see that that's the rate, 102%. But I'm trying to figure out the interest rate. This is like the total percentage of the 250 that he will be owing. But if I want to know the interest, only the interest, I am going to use 2%, right? Because this is adding that 100 just to make the equation easier to do, the 100%. So it's actually 2%. And and you see it in the, what did I put? So the 1.02 in the first, 1.02 equals 102% in the first equation or expression, and then the second one is a little different because this would not be the interest rate. That would be like 500% interest, which doesn't make a lot of sense. It's way too much. So if we figured out, well, how did I do that? 2% of 250. So if I know 2% is the interest, 2% of 250 gives me 5. So then that would be the interest. That would be the actual interest. So 2%. We know 2% is the interest for both. That's the target interest for both accounts, or for both loans. Now for part B, it says which expression represents the amount that he would owe his grandmother and which one represents what he would owe the bank. So I'm thinking, well, I know that whenever there's an exponent, I know that's exponential growth. I know that it's going to keep going more and more and more and more each time. There's not a constant rate. So that would be the bank, which means the other one has to be grandma. So the bank has compound interest. Grandma has simple interest. And then for part C, it says to evaluate each expression. So that means we're going to solve each expression. And in your calculator, this one is going to be different in your calculator. So if you're on your phone and you turn it sideways, you get more options on your calculator. So you would type in 250 times, then you would type in 1.02, then there's a little option, there's a little button that says x to the y power. Click that, and then press 8, and then equals, because that's showing that this 8 is going to be the exponent there. You should get $292.91 for the bank. So $292.91. Let's see for grandma. Grandma's easier because, 8 times 5, 40, plus 250 is 290. So it says, should he borrow money from grandma or should he borrow money from the bank? And I'm thinking grandma's the way to go because she's gonna charge us a little less with her simple interest loan. About $2.91 cheaper going with grandma. Okay, that is the end of 8.1.3, and I will see you guys later.